Hi everyone, welcome to the first episode of Bytes and Backpackers. In this first season, we are going to talk about Kotlin Multiplatform, a cross-platform framework to develop mobile apps for both iOS and Android. And we'll discuss about how this framework is getting adopted in production in Wild. And for the first episode, we have with us Ritesh Gupta, who is working on very famous OTT platform. And he's going to share with us his experience as an iOS developer, that how Kotlin Multiplatform has engaged with different iOS developers and how he also helped in adopting KMM in his production apps. Also, his talk got selected in DroidCon Berlin, which is about streamlining generation of the archives on production for both iOS and Android, which are present in first different repositories, merging it in one monorepo, and also some of the iOS hiccups or issues that he has faced and got over with. So yeah, let's start. Hi Ritesh, welcome to the first episode of Bytes and Backpackers.
Thanks, Amanjeet.
So I was very curious, coming from Android background, that an iOS developer was onboarded to Kotlin Multiplatform and got that interest in the very starting days of Kotlin Multiplatform, when the only developers trying the framework was actually TouchLab, I think. So I would be very curious to know that what was the first thing that got your eye on Kotlin Multiplatform in the presence of other cross-platform frameworks like React Native. And I remember Flutter was very naive at that stage, but yeah, there were other things. So what got your eye on Kotlin Multiplatform?
Yeah, so before KMP got excited me, I had played with Kotlin before. And coming from iOS, of course, I have the expertise on Swift. So now after seeing that the similarity in the language between the both, even though they have a lot of big differences, but if you look at syntactically and other things, they look kind of similar to each other. So the comfort of the fact that I can write something shareable across both the platform and Kotlin, I think attracted me at that point of time. I don't really remember the exact moment which got inspired me, but I remember talking to Kevin Gallagher, I guess, in DroidCon 2019, where I think at that time KMB was just on the rise. And I remember chatting with him about how, as an iOS developer, I can figure out this framework and what should my approach, after seeing, I think, a couple of talks in the DroidCon New York and maybe some other platform, I don't remember exactly, but so 2019 was the time, the summers basically was the time when I got excited about it and thought, let's give it a shot and, try out this interesting framework by JetBrains.
Mm-hmm. So I would also like your opinion on one of the facts which I have noticed in the community whenever any new framework is being launched. So there is Jetpack Compose, there is Swift UI, there is macro benchmark, lot of things. So people start using it when even they don't need it.
Yeah.
So what should be any approach of any developer in intermediate or beginner, whatever level he or she is coming from? Should they just start with the buzz? And because there is a lot of FOMO with these frameworks, because you see in Twitter and on other platforms that everyone is using it, so should I start it? So I would also like to know that, did you started with the same mindset, or there was a definite use case? And there is, because you have worked on production. But I would just want to know your mindset behind the beginning of your journey.
Sure. So initially I did not have any production app in mind. I have traditionally worked with a lot of side projects. That has been in my DNA. Whenever something new comes out, I do try it out, make a simple POC, and think of a use case which I can maybe apply on the new framework or whatever, and use that as a platform or an opportunity to try out a new tech. So I remember that in 2019 in summers, like I think SwiftUI also came out, which was a new declarative way of writing, iOS framework. So, and KMM was also kind of on the rise. So I thought, can I use KMM and SwiftUI and try out, the cutting edge of both the platforms, because SwiftUI was just new, it was just out in the market, and KMM also didn't have too much of documentation either, or any blog posts as per se or any talks per se. So I had made an app long time back. It was called Cherish. It was about like saving your favorite restaurants and adding some tags to it. So that was way back in 2014, written in Objective C. But I thought, let's give it an overhaul. Let's make a video of that. And at that time, I was using I think, what do you call that? Foursquare's API, which is a location API or restaurants API. But I think I'm not sure if it still continue or not. But I thought, let's revamp that V1 into a V2 and use something like a Zomato's API and see how I can share code and to what extent can I share code. So it started as a side project, like experiment project, but I had some picture in mind that ultimately it will be a useful app for me. So it's not like I just make something for POC, it has to be useful to me as well. So whenever I in my daily life as well, I do feel that there's a need of an app for a particular use case. So in this space of saving the restaurants, I felt that I could still not attach tags to it or whatever. So I tried, maybe let me solve that problem for me, and why not try out new technology, because it's my side project, right? If things goes wrong, it's not like I'll be delayed by something. So that's how I got into this, and as a side project I started making a simple app using SwiftUI and KMM as a shared framework. I did not make an Android app for that at a time. So I just wanted to try out how I can use a Kotlin framework in a iOS app. And at that time, I tried the simple monorepo architecture, which is recommended by JetBrains, or at least if you download their sample project, that's how it's done. Or if you try out the sample plugin, which is now available in Android Studio. At that time, I don't think they had a plugin either. So now, but they have a plugin now, which is easy to kickstart a KMM project. So if you kickstart a KMM project, it gives you a monorepo, right? So it has three important folders: the KMM folder, the iOS folder, and the Android folder. So at that time, I thought, let's not make things complicated. Let's see if I can work this monorepo or not. And that POC turned out to be a very useful app for me towards the end. And that app was not just for me, but I used it as a POC to pitch to my company as well when a requirement came in, when an actual production requirement came in. Yeah.
Okay. Yeah, I think this course of path really makes sense, because whenever there is any framework, I think first of all, I would also like to know about your opinions on this, but there should be no kind of FOMO for any framework.
Exactly.
And you should get on board at your own pace. Try with sample apps, because that will just get you on board with all the jargons that the framework has, because I'm pretty sure there are a lot of things like monorepo, as you said, there must be something in threading or Kotlin native or whatever jargon that this framework has. And then there will be a time when you will think in the path that, is this justified for our production usage or not? And that at that point of time, it will be more justified rather than just trying it just because you saw a tweet or just because you saw something on social media, right?
So I mean, definitely, you should not try out things because the community is trying out. You should be comfortable trying it out at your own pace, as you mentioned. You should have time, you should have mental time and physical time as well, right, to try out something. So if your work is not allowing that to be, it's fine. You can continue towards the end, right? There's no train that you have to catch. So don't be in a fear or in a FOMO. It's easy to say don't have the FOMO, but ultimately some sort of the other you have, right? But it's never a good idea to start a project because of that. I would suggest that do it because you're passionate about it, or you have a little connect about it, right? So what connected me to KMM was the fact that I had already used Kotlin before, so the familiarity of the language was there, and Studio was also familiar ID for me, even though I use Xcode for my bread and butter, but Studio was familiar because I have already shipped apps, Android apps in Play Store as well. So I knew what Gradle is, I knew what Manifest is, I knew a bit of Android Studio and architecture and all. So that helped me get into it. And at that time, I did compare with things like Flutter, which was using Dart at that time, and Dart was not so mature at that time. It was just a beginning, a new language. Right? Now it's pretty sophisticated now, I guess, but at that time, it did not have too much of features. And if you compare with React Native, then you had JavaScript, right? Again, these languages are not a barrier, right? But you should be comfortable making these side projects. Side projects are meant to give you fun.
Correct.
So if you don't enjoy that period of making a side project, there's no point of doing it, because you're dedicating your own personal time on that, right? So
Correct.
you should have at least fun and enjoyment in that phase of doing it. So yeah, that's I think what my recommendation would be.
Got it. And like when you got on board with all the framework jargons and like what is exactly Kotlin Multiplatform, when was the time when you thought like, okay, I have to like get on board every other developer in my organization and maybe think more seriously on bringing this in our production usage? Because there is a level when you use it in a side project and then you get serious with it.
Exactly.
And then you also think of more variables, because till the part when you are working on a personal project, you don't have anyone to convince to.
Exactly.
And there is no one working with you. There might be, but most of the times you are just working like alone on a side project. So what actually made you serious to work and to like bring it in your organization at that time?
Yeah. So I was just chatting with my director at that point of time, where he told me that he has a client who they liked a lot, and they wanted like 4 apps, that is iPhone app, an iOS app, Android app, as well as iPad app and an Android tablet app as well. Now the iPad and the iOS app, they were different in nature, because one app was doing something else and one app was doing something else. So they had to share a bunch of core capability like networking, caching, right? Maybe analytics as well. So they shared a bunch of things. That is all the 4 apps that we had to build, but they all had different UI. Like Android has about Android design, like material design for that, and iOS had their own iOS specific design that we had. So we wanted to keep the platform specific UI feel to it as well. Right? That's why we didn't go with any other platform like React Native or Flutter, because we wanted separate UI for the look and feel of in the particular platform. So I was chatting with him that this is what like he was telling me that this client needs these many products. So what can we do about it? And I happened to have that POC ready with me in my laptop. So I demoed it there and then. And this is how we can use KMP, and this is what technology is about Kotlin Multiplatform. And I think he liked it in the first go. And then after that, the real challenge came in, where I had to figure out, as you mentioned, the actual world challenges. For example, the simplest challenge, or the first challenge which came to us, was that traditionally KMM is a monorepo. But in any org, you will of course have separate repos for separate apps. So we had 4 different repos for 4 different apps that we had to make. So we could not use a monorepo in that case. So the first challenge that came to us was that how will the CI/CD work? Now we didn't have any expertise yet. Because generating a framework from KMM, you need to know what Gradle is and what Gradle tasks are. And at that time, we didn't have too many tasks as well, the default tasks. Right now, if you look at the Gradle task open in terminal, it'll list down you 50 tasks, right? And and some of them are really mature tasks now, which gets things done very easily. For example, a fat framework. Now iOS has 2 platforms to support all the time. One was Simulator, which uses your Intel architecture, whereas the device uses an ARM architecture. With M1 now coming into picture, you will have an ARM on device and ARM on Simulator as well. But traditionally, we had 2 different architectures. Now, if your KMM library, you're shipping a KMM library, you need to support both the platforms as well, right? And that's why you make a fat framework at that time.
Correct.
Now we have a different framework called XC framework, which is even a better version of a fat framework. But at that time, we did not have XC framework very mature, right? So now fat framework was not supported out of the box. So you had to figure out how to generate two artifacts, combine them together, right, and then ship it to the iOS team. So there were a lot of these kind of challenges which came, immediately, because now I was not using it as a side project. On side project, I can toggle my script to generate a simulator or to generate a device build, right?
Correct.
But for real app in production, you want to run test cases, you want to run all things on CI. So you don't know where you are running your app. You might be running your app on device. You might be running on simulator as well. You are not in control anymore. So you have to make sure that you take care of all these nuances that comes with iOS. Android has always been an easy breeze, like a journey, where I think I only had to spend a couple of hours to figure out how to do things on Android, because the Maven has a in-house support for it. Luckily at that time, GitHub started a thing called GitHub Package Registry, which Maven also is a plugin for that. It's called Maven Publish. So with one Gradle function or task, you can actually publish your .ar file, which is the Android artifacts, directly to a Maven repository. And GitHub took care of all that process behind the scenes for you. So with this one Gradle task, it was taking your local generated artifact.ar file, and it shipped it to the Maven's repository. And you could see the snapshot of that in a GitHub project as well via the GitHub package registry. And your Android folks simply use the Maven Central and download it as like a regular dependency. So for Android was a simple case, right? But the challenges that I had to figure out and was the iOS part of things, and that's where I think we can discuss further.
Yeah. So I think what the experience that you are sharing, I believe it is still a framework which is Android first.
Yep.
And the feeling which I am having, like, because there are a lot of other things which might not be working in Kotlin Multiplatform, and then you might need to find a way out of it.
Yep.
So one of the things which I could think is, because you said like Kotlin Multiplatform is a shared, like a code base, there is a shared code base, and then you have UI, Android and iOS, which is like the main power of this KMM framework. But now the irony is, when I was working on KMM, I actually find it hard to really find the one library which is working on like both frameworks. Like for example, as you mentioned, like we can share analytics, but if you see analytics, there is no analytics library right now which I could really think of at that time. That can be easily shared with like both frameworks. Actually, analytics will not be a good example. There might be, like for example, networking. Networking is actually a good example, because I remember when I was like working on Kotlin Multiplatform at that time, OKIO was not really supporting both the frameworks. Like right now, it is a Kotlin Multiplatform first framework, both iOS and Android. But at that time, these things were not like for both platforms. So did you face that kind of difficulty as well? And do you think this is kind of a showstopper for getting on board to this cross-platform like Kotlin multi-platform thing?
Yeah, so that's the first question which my team also asked, that what about the community support? Like, do we have the libraries already existing or not? So luckily in 2020 early days, that is the January, February, March month, the first quarter basically, we had basic support in-house for us. Like as you mentioned about API, in 2020 at least we had this framework called KTOR. So KTOR had, it was a pure KMM library which you can reuse for iOS and Android both. Right. Similarly, we had I think a SQLite kind of a thing also available for both the platform as well. So caching was also sorted. So you had networking, you had cache, you had network sorted for you. I think then the next couple of layers are what? Navigation, right? Or analytics, right? And your repositories, your view models, right? Now, if you look at everything which is non-UI, that you can write yourself in Kotlin, right? For example, your repository or your use cases or your view models, you can write yourself. There's no issue with that. Navigation, I don't know if you can, I mean, whether you should write in KMM or not. I mean, of course, technically you can write, there's no harm in that. But whether you should or not, that's a separate discussion. And analytics, as you mentioned, there is no library for analytics yet, but it's not that difficult to make one. And when I say make one, I don't mean that you have to publish a KMM repository for that. You can actually write your business logic in Kotlin and write a simple interface which exposes the basic get and set methods of any API. So let's say if you're using an analytics library, let's say Mixpanel or Amplitude, whatever you want to use in iOS and Android, what sort of methods do you have? At max, you have 4 to 5 functions. Right? You set a user to an analytics object, or you set some custom properties to it, right? Or you fire an event, right? So these are like 4 or 5 functions. You can hide those 4 or 5 APIs behind a protocol or an interface in Kotlin, and you can use an interface in your KMM project, right? And use this interface as a dependency when you initialize your analytics library, right? Correct. So now you can ask your platforms to inject an object which implements that protocol or interface
for both the platforms.
So ultimately, it's just one file of work for both the platform. So you can still use your iOS CocoaPods, Amplitude pod, and similarly for Android as well. So you import them separately, and then you can simply ask these classes to implement your protocols or your interfaces, and you inject this object that you have created on both the platforms to your KMP library. Right. So that way you've hidden your 4 or 5 APIs, the basic CRUD operation you can say of analytics. But you kept all your business logic in KMP itself. That is, when you want to fire an analytics, you want to capture, let's say, your score position. Maybe you want to capture your item index, right? So all that you can still capture in your regular code, which is your KMM project as well. Maybe you want to capture the user data attached to it, right? Or maybe you tapped on an item, you want to see which item you tapped. So now all those things are still part of the KME project. The UI is with the platform, but the moment you send a tap signal from UI, we designed our KMM in a way that we reuse KMM till the view model layer. I'm not talking about the Android specific view model, which is lifecycle aware view model class, but like an MVM pattern view model class, right? So, correct. So the architecture we followed was whenever you receive a user interaction, we simply followed that user interaction to KMM, and KMM simply did the operation based on the user interaction. So that way, we had all the data inside KMM all the time, and we could use analytics or share analytics as well. Because I specifically remember this use case that came to us that we had to share analytics as well. And it was an easy job, not a difficult one.
Got it. So we'll definitely deep dive on the numerous challenges that you faced and what is an ideal pattern that you should follow and like what was there in your case. But I would also be curious to know that since like when you were starting this project officially in your company or organization, how did you convince the product and how did you get on board other developers? Because I see that you have curiosity and you are very flexible to learn about different languages as well.
Yeah.
And I can see that there would be a lot of showstoppers for other iOS developers.
Yeah.
And since they are not even familiar with the Gradle language or Kotlin as well. So what was your approach and what can you suggest to our listeners as well, that what should they do to surface every other blocker that they might face, and how to solve it and how to be like persuasive for other engineers and product as well, which our listeners can also like do.
I think what worked for us was the fact that I had a backwards approach to it. So rather than telling them what KMM is, I showed them the actual product. I showed them the POC, that this is what the UI is looking like. I showed, like for my iOS team, I showed their Swift UI code to it. I abstracted out the logic of getting the data for the UI. So I showed them, hey, I'm using Xcode, I'm using Swift UI, and I have just imported a shared framework which is coming out somewhere, and now I can just and they could see the fact that the app is running the same way any Swift UI app would run.
Got it.
And then I slowly, from that product that I showed to them, I moved backwards that this is that I'm using KMM for this, right? But you can see you can still use Xcode for this, right? So for first I had to make them comfortable of the framework or the environment that they are gonna be using for the next couple of months, right? So the fact that they could see that, hey, I'm running an app using Xcode, that gave them confidence, right? That they still have Xcode with them. That's very important. They could still use the simulators that they have attached to it, or they could still run on device as well. So all that familiarity is what gave them a push that this is what their home ground is, and all they had to understand was that they were consuming a library which they anyway consume all the time. For example, LMO5 networking, right? or for analytics as well, or maybe for reactive, say for RX as well. So we are used to consuming dependencies. So KMM was nothing but a dependency as well. It's just that it had capability of getting the data for you, and now you're just using that data to show it on a UI, the way you want to do. So this backward approach made them comfortable. And for the very first project, I took the initiative of doing the heavy lifting of solving all the iOS specific problems, so that they are not exposed to the difficult parts of it. And once I am through that phase, then they could see the better picture of it.
Got it.
Right? Because once I have the solution in hand, then it's easier for me to explain as well, like how it's going to work out. But if you challenge your company or your team that, hey, we have 10 problems to solve, and that too in an alien world where they're not familiar with, everybody can be scared of it. People can be scared of. So rather than scaring them with new technology or new tooling or new platform, the approach which worked for us was that I took the initiative of making sure I had almost all the problems solved for me as a POC. That is the CI/CD process, the framework generation part of it. How do I integrate with CocoaPods, right? Because they used to use CocoaPods for dependency injection, dependency management. So I had to make sure that they are able to use pod install, right? I don't want to override their pod install in a way, right? So my objective was to make them not realize that they're using KMM, right? That was the idea. That is, they should be oblivious of the fact that how is this being generated. I could give them a JavaScript library as well, but they should not be affected by that. I could give them a Flutter library as well, but they should not be affected by that. Right? So that was the idea. But you still cannot hide the fact that you're using a library. Why? Because there always be some nuances that will expose your source. For example, in our case, KMM converts Kotlin to Objective-C first, and then Objective-C gets to Swift. Now this transition that happens, now you lose a bit of type safety as well. You do lose a bit of typeness that you get from Kotlin and Swift. Objective-C hasn't been that type safe as Swift is or Kotlin is, right? Mm-hmm. So this bridging that happens via Objective-C does make things a little not difficult or complex, but it gives you the hint that something is not Swifty enough.
Yeah.
Right? Yeah. Because in Kotlin, the Android team will see the Kotlin API as it is. The Kotlin code that I'm writing in KMM, the same code as it is, they will see same thing in Kotlin as well. For example, seal classes. If I use seal class in Kotlin in KMM, the Android team will receive the seal class itself. Mm-hmm. But if you convert seal class to a Objective-C world, you actually get an inheritance.
Got it. Yes.
Because every seal class is also inherits the base class as well, in a way, right? Mm-hmm. So in iOS, you actually get an inheritance on objects, and that makes you confused that I wanted to use an enum. So in Swift, we do have a very powerful enum where we can attach objects to different cases as well, which is nothing but like a seal class in a way, but a little different. But the power is pretty much the same. So I was expecting that the seal class will be converted to my powerful enum, which is there in Swift. But I forgot that Objective-C doesn't support that powerful enum. So because Objective-C is in the middle, it makes things a little complicated. Like it does brings Objective-C-ness to the APIs that you would like to see more Swifty. So you don't get the Swifty API, but even before Swift, we were still making good apps.
Correct.
Right? Apps were still getting Apple awards, right? So you could still make good apps with Objective-C. So that proves that language is not the barrier of making good app. Mm-hmm. And that's what I explained to my team as well, that hey, even though we are losing a bunch of things, right, but we are still getting a lot of Swiftiness, a bit of Objective-C-ness as well, but that should not block us or stop us from making good app. Mm-hmm. Right? So because that hasn't been the case, right? People have shipped great apps with Objective-C before as well. Very efficient, very performant app as well. And still Objective-C app loads way faster than my Swift app. It's still true to do right now as well. Yeah. I was able to compile my 5-year or 6-year-old project in Objective-C, but I can't compile my first Swift code right now because Swift code was not backward compatible at that time. It was not ABI stable.
Correct.
So that's why this is how my approach was, because Android team was always comfortable. They were like happy about it, to be honest. But yeah, like that's how I think I took the charge of iOS, where I did all the KMP and the iOS work as well, made sure I had all the answers that they were going to ask me, and also I was ready with the risk that we are taking as well. But yeah, like so,
Yeah.
it was a bit of a challenge, but I think it worked out pretty well. It worked out so well that after that project finished, I think the company ended up having 3 or 4 more clients.
Oh,
Yes, because everyone loved the entire fact that you could test the code once, you could write the code once. The everything was at one place. There was no platform specific bugs at all. So those were the goodness that we got from that entire framework. And even today, I think after it's been what, like 4 or 5 years now, or 3 to 4 years now, and I think they're still using KMM clients that they are getting, I guess. Yeah.
got it. So yeah, it's actually very smart that you show them the strengths that you have.
Yep.
And the only blocker I could also think of, because honestly, a software engineer is like an engineer who can be comfortable with any language. That is definitely one thing. So the only thing which I personally also get uncomfortable with at the first, at the first instance of trying any other language is actually IDE.
Yep.
Because whenever
Yes.
that changes, your environment is changing.
It does.
So you want to be considerate about that, instead of the fact that you are trying a new language. I could actually share a very common example that I felt when I was trying this new language. I think it was C++. I was very uncomfortable when I was trying with any other IDE apart from IntelliJ. I literally bought the membership because I need IntelliJ environment.
Yep.
So I would completely agree that just show them the strengths.
Yep.
And make them comfortable, and show them that the environment is not changing.
Yep.
And you can still code in Xcode, and there is nothing to be afraid of.
Correct. Yes.
That's a very good takeaway. Coming back on the structure of Kotlin multi-platform apps. So I remember you said that you had different repositories for iOS and Android, and then you had to then you need to bring that in one central monorepo. So was that a simple migration, just cloning that in one repo and just pushing it, or that you faced a difficulty in bringing that and centralizing it in a monorepo?
It was actually the other way around. So by default, KMM gives you a monorepo, the template of it, right? What we had to do was make it separate and distribute it into different repos. So the ultimate goal was that the KMM in a monorepo works in simple ways, because you all know the relative path to it, and all the relative path to all the repos, all the platforms or the KMM, they all are local to your machine as well. So it's pretty easy to compile code and refer to your framework and pull it and use it in your UI code, right? But when you have 3 different repos sitting in 3 different machines, and you don't have any access to them, now how do you make sure that the frameworks are generated properly, and where do you save them? Once you save them, how do you convince CocoaPods to pull it for you as well? Because Maven was sorted, as I told you, there was no issue with that. But CocoaPods was not a concern, but it was a challenge definitely for us. But I knew it will work out, because I think at that time, TouchLab probably they proved that they could use CocoaPods in a local folder structure as well. So if they were able to use locally, then I thought maybe remotely is also possible, right?
Mm-hmm.
So I dig deeper into it, went into understanding how CocoaPod work. I've been using CocoaPod for 6-7 years, but I never spent time in documentation because it was never required, right? I've published a lot of pod specs as well, but the pod specs of a regular iOS project was very straightforward, because CocoaPods basically needs 3 things. Either you give them Objective-C file, the source of it, it will compile and give it to iOS, or you give them a Swift source, again it will compile and give it back to the iOS, or you give them a location of a framework file, which is already bundled basically, right? It also knows how to use it and give it back to iOS to consume it, right? Now Kotlin is neither Objective-C, neither Swift, so the 2 options are ruled out for me. The only thing I had to figure out was how do I convert Kotlin to a framework file, which luckily Gradle had a plugin for it. And then once I've made this artifact .framework file, I had to figure out two things. One is where to host it first of all, because I can't host it locally because they are separate repos. So you host it remotely somewhere in a repo somewhere, maybe in a release or maybe in a folder, whatever. And then how do you tell CocoaPod to fetch it from that? And imagine everything is happening in a private repo as well. So publicly, again, things are a little easier, but in a private repo architecture, you have to make sure you have proper keys attached to it. I'm not sure if we had personal access token at that point of time, but now we have. But maybe we had at that time as well. So we use one of the techniques at that point of time to make sure that all the repos have access to this KMP repo, so that they can access this framework file and AR file that both the platforms need. Right? So this was the challenge for us. So we had a monorepo given to us by KMM, but we had to distribute that to different repos and figure out all these problems that came in along the way.
Got it. So it's like there was a iOS repo,
yes,
which had UIs and view controllers and all.
Yep.
There is an Android repo which has activities and all.
Correct.
And then there would be a mono repo which Kotlin Multiplatform by default generates.
Yep.
And that would give you that .framework file, which is going to be pulled by this iOS repository.
Got it.
And is that the same thing which Android will also use, or is it going to be R?
.ar file, yes.
Yeah, that Android library, right?
Yes, exactly.
Got it. Yeah, that is interesting. So there is no need to bring everything in one place, and because honestly, I thought that you had to bring all the code in one, view controllers and all of that, and activities at one place. So yeah, that is interesting that you can still make it work, even if they are existing in like two different repositories. Right?
And the beauty of this is that at any point of time, if you want to switch back to monorepo, it's possible.
Yeah,
it's really interchangeable. At any point of time, you want to make change to monorepo, or maybe from monorepo you want to go to a multi-repo. At any point of time, everything is possible, right? All you have to make little changes to your CI/CD process, and that's it. So that's why it's very configurable. Because traditionally, when I worked on my POC app, I had a monorepo. But for the POC that I had to make from a company, I broke that monorepo into multiple repos to test out all the CI/CD, the GitHub actions, in the framework generation, and everything. And again, it's very easy to bring all the pieces back and also use a monorepo. So it depends like what you want to use, but that way it's not a very big challenge to move from A to B or B to A. It's totally doable.
Got it. So this iOS and Android repository that you had was the migration like just straight away, like let's go to Kotlin Multiplatform, and the other day you are Kotlin Multiplatform, or you took a approach like, okay, this feature we'll migrate like at in this sprint, and then other feature in this sprint. And what was the strategy that you and your engineers took? And was it based on some kind of like a risk analysis that, okay, like this feature is really core, so we'll not touch that, and we'll pick this feature first? So what kind of strategy was taken by your team?
So first of all, KMM works with both kind of projects, greenfield or brownfield projects, right? So and at that point out, luckily I was working with a service company, so it was a project from scratch. So there was no existing code that I had to adopt to KMM, but again, it's very easy to adopt to a brownfield project as well. All you have to do is again import the library and start using it, right? So there's you don't have to change any CI/CD or any Xcode settings to make it work, right? For it's just a new framework that you can use, right? Imagine that you are not using Alamo for networking, but using KMM for networking. As simple as that. But for me, at that point of time, I was lucky enough that I could get a fresh project from scratch, where I could do anything that I wanted to do from the day zero. And KMM was always about a sprint or 1.5 sprint ahead of both the platforms.
So
because I needed some time to code that common logic and prepare some shippable framework that they could use once they start their sprint. So this was a strategy that will always keep KMM ahead of both the platform, so that once they start their work, they will have something to consume and something that they can start working on immediately.
Yeah, like that is really good, because that adds to other strengths that you can show to the fellow iOS developers, right? Like there is not only shareable code base, the side effect is actually releasing faster, which is a huge problem for a lot of teams.
Exactly.
That's interesting. So the other thing which which I was also talking about this other like developer, one of my friends in PhonePe. So is it like that Kotlin multi-platform can still be used for some screens, but the other screens can still remain native and still be in their own frameworks? So is it possible that I can like maybe do Kotlin multi-platform for my add to cart feature, and then everything is remain untouched?
Yeah. So you mentioned that like you want to keep one screen native. First of all, every screen is native because KM doesn't touch your UI code. So by default, every screen is natively built. We are not touching your view controllers. We're not touching your Swift UI either. You still write your controllers. You still write your Swift UI as it is. So even if you use KMM, you still have to write those views for you, right? So we're not replacing your view. So anyway, whether you use KMM in the entire app or whether you use for a single screen, your screens are still natively running, but like on device or on simulators, right?
Mm-hmm.
That's one. Secondly, yes, like it's totally adoptable. It's totally that's the selling point as well. If you look at the KMM website as well, that's one of the selling points, that you can adopt KMM at any point of time, at day 0 or maybe at day 100 or maybe day 1000. It doesn't matter. Because again, as I told you, imagine you're not using retrofit, but I tell you that, hey, there's a new shiny library, networking library that you can use, which gives you data as well from the API, right? So will that stop you, right? No, right? Because ultimately, like retrofit, you're consuming another library. So you can still write your UI code in XML or views or compose or whatever works for you, and you can adopt that to an existing screen. You can adopt to a new screen as well, or you can adopt it to half a screen, maybe a cell, maybe a collection view, whatever you want, right? It doesn't matter. You can even adopt to maybe just for logging as well. Right? You just want to migrate your logging to a centralized logging structure. Even that is possible. Maybe you want to just share your data parsing logic, right? Even that you can share. Maybe you want to share, I don't know, like image downloader, as simple as that. Again, you can do it as well. So you can keep your other networking stack as it is, but you can just replace your image downloading API with your KMM downloading API, right? So everything is plug and play. Everything is composable, right? In a way, yes.
Yeah.
So that's why there's no limitation as such when you use KMM in any scenario.
Got it. Yeah, the only hiccup I could think of, because in one of my previous companies, we thought that we are going to try Kotlin multi-platform, but the only thing which stopped us was the coupling with the code base itself.
Okay.
Because it was not in a shape where you could achieve that shareability. Like it was the code base that we wanted to share, that first needs to be in a separate module.
Yeah.
So the problem is modularization.
Yeah.
So if you want to make like a feature which is in Kotlin multi-platform, you need to ensure that it is isolated enough to like go shareable.
Maybe not as well in a way, because so let's say even if you have a messy code base, but that messy code base will be separately hosted for iOS and separately hosted for Android. Let's say you don't have any architecture. Every entire app is one file. Imagine that, right? Even still you can use KMM. How? Because we don't want to reuse any iOS code. We don't want to reuse any Kotlin and any Android code either. Because you just can't reuse Android code directly as well. Because KMM is not Android, right? It is a non-Android framework, right? So anyway, directly you can't just pull in the files from Android app and you start using KMM. Unless it's a separate Kotlin project altogether. If it's a bunch of Kotlin files, you can drop it. You can just drag and drop. Right? That is there. But let's say your entire app is in one file, and you want to replace image downloading. You can just make a new module in KMM, write Kotlin code, import ktor, hit your network call, hit the downloading file, maintain an internal caching mechanism as well, and then expose one simple API of fetching an image, and then now go back to your messy code. Replace that messy code with your new KMM code. That's it. So that way you don't really need to clear your mess either. But using KMM, you're kind of clearing your mess as well, because now you have removed that logic which was tightly binded to each other in your messy code, and you're using a more isolated framework directly in your iOS or Android project.
Got it. Yeah, I think it's like if you think that, because with KMM you need to also decouple your business logic, the Kotlin business logic which you want to share, either you can go and just do that, modularize in a way that you can share it,
Yep.
or you can, as you said, like go and develop that by scratch.
Yeah.
Because like why not? Because the type of strengths that you will have down the line, you don't want that mess to be there anymore, right?
Yep.
And you can just change your code paths to just point at the new thing that you are going to create.
Yep. And at that time, you could not even use retrofit as a KMM library.
Yeah, that's true.
You could not use OKHTTP either. All you had was Ktor.
Yeah.
So anyway, you could not reuse your existing Android code, even if you want to.
Yeah.
So that's why we had to. You can write separately and then move on.
Mm-hmm. Yeah. So coming back on this topic again, like the different libraries which we are discussing. So I'll start with listing the basic operations that app does, and you can start naming all the libraries that you had at that point of time, which I believe you said that there was only Ktor, but I think you can still mention the libraries that you see now, which are there and that can be rightly available for any KMM framework. So starting with networking. So for networking, I think you said like Ktor was there. But right now OKHTTP and OKIO, with all of them coming into Kotlin Multiplatform, I think they can also be directly used, right?
I'm not sure about the OKHTTP. I haven't used that yet. But Ktor, yes. From day zero, they have been Kotlin Multiplatform first as well, I think.
Got it.
So, and Ktor is reusable not just across UI platform, but backend as well.
Got it.
Yeah.
Okay. So Ktor is the thing. And OKHTTP, because I think I have seen that these guys from Square, they have provided a Kotlin multi-platform first support, because when I was working on this, I was like kind of using it. So I remember, I think they have done it, but yeah, we can check.
Yeah, everybody is catching the train now.
Yeah.
So nobody wants to be behind because it's catching up. So
yeah. And second, like serialization, deserialization, because you'll do networking call and then you want to serialize the data.
So I think there's a Kotlin X library, I guess, right? So Kotlin X gives you all these libraries as well, which are also multi-platform first. So we had a library for serialization, deserialization as well.
So at that time also.
Yes.
Got it. Yeah. And for database?
I think database, again, we had a SQLite wrapper for us. Which again allowed us to share caching across both the platforms. So we had library for caching as well.
Got it. Now there are libraries like analytics and other tools as well. So there might be also situations when you started your Kotlin multi-platform project, there could be a situation that there is a third-party library that any company uses, but they don't provide the Kotlin multi-platform support.
There are so many, yes.
So what was your approach in those cases?
So generally there are two ways you can go about it. One way is we call them. One way is you can use something called as expect actual. Right. So imagine expect actual where you make some expect classes. So it's like expectation. You're setting up an expectation that this class will exist in future, and so they are like interfaces, you can say, right? But tailor-made for KMM. So you can write some expectation that maybe, let's say you want to use Firebase, right? At that point of time, there was no library for Firebase either. But in my side project, I did use Firebase as a database. So I figured out a way how we can reuse Firebase and also use KMM in Firebase as well. So for that you have two approaches. One is expect actual. Write some simple CRUD operations for Firebase using expect classes. So you can say Firebase interface as an expect class. Write your get, post, put, patch, your functions without implementation. Then your common main and Android main will expect. So you have three mains, right? You have common main, iOS main, and Android main. So common main generally have the expectation classes. And the moment you have expectation classes, to compile the entire project, you need to have actual classes in the platform folder as well. So the moment you write an expect class called Firebase interface, you need to have a Firebase implementation for iOS and a Firebase implementation for Android as well.
Correct.
Right. But now this approach forces you to somehow import Firebase inside KMM as well. Because how will you write the actual Firebase iOS class until you have the actual Firebase iOS library?
Correct.
And same for Android as well, right? You need to import these native platform libraries first, and then implement your actual classes, right? So technically it is possible. You can import these external frameworks as well, but they are very difficult to do. Like there's no simple easy way of importing these right now, right? Or at least at that point of time. When I started this project. So the other way is don't use expect actual. Use simple interface classes. So you make a simple interface class called Firebase interface, which doesn't need to provide actual classes in those folders. So in common main, you write a simple Kotlin interface called Firebase interface, and then in your regular analytics, like let's say we want to fire analytics and view models, right? So now you can simply call this Firebase. And then you can call this Firebase APIs, that is your interface class, directly in your view model. So you can make your view model inject a Firebase from outside. So now when you're actually making a view model class in your native platforms, you can inject your platform specific Firebase classes as well.
Got it.
And internally in KMM project, your KMM view model are using the KMM Firebase interface internally. And on top of the interface, you can write complex business logic as well. Like for example, Firebase has its own way of manipulating data. You have documents, you have folders, right? There's a Firebase store now as well. There's Firebase real-time database, right? So you have specific JSON structure for them to support. Now, so all this business logic of how do you route to a page, how do you fetch a particular data, how do you query for a data, all that business logic could still live in the common sharing code. All I had to expose from outside was the current operations of the Firebase interface, and that's it. So on both the platforms, all I had to do was write one class or one file, which was roughly about 150 lines of code, not more than that, where I imported the Firebase iOS SDK, I imported the Firebase Android SDK on both the platforms, and I made both the platform conform to my common KMM interface.
Got it.
And that's it. Now I could inject these classes to the view models that I was using. So that way you can bring in any library in the world that you want to use. And that's how we brought in, I think, Mixpanel as well at that time. Mixpanel again didn't have a KMM project, but we wanted to use Mixpanel, right? So again, we wrote a one simple wrapper or an interface class, and we implemented both of them, and that's how it was done. So you can onboard any library you want to use right now.
But how friendly other like SDK developers are really with this kind of environment? Are they willing to do it, to do this migration? Because if it comes to writing, like I think now it is pretty much okay, but at that time it was like Firebase, like, which is a very common thing. It was not having Kotlin Multiplatform support. So are the SDK developers right now open enough to support it at the first, like as a first class citizen, or there is still some gap which needs to be filled?
I think they're adopting, that's for sure. The list has grown a lot now. If you look at the open source projects which support KMM now, I don't have the diff yet with me, but we can attach it maybe later in the video. But like maybe if we had, let's say, 15-20 libraries at that time, but now easily I think we have more than 50 or 100 libraries, I guess. So we do have good support now. Like I remember at that time we were getting the support for using shared preference and user defaults using the same, so I think it's called multi-platform settings.
Oh, okay.
Yeah, and also we could reuse or share the keychain of both the platform as well. Right? So we had library for that as well at that point of time, because we needed both the frameworks. We wanted to show the secure credentials in the keychain, but other things in the shared default or shared preferences as well. So even at that point of time, we had these supports for us, and it was not given by, let's say, big companies, but by folks like us who were caring enough that they want to ship KMM basic things pretty fast. So I think over the last couple of years, a lot of folks have chipped in. A lot of good public libraries are supporting KMM now, like Apollo. Apollo at that time was not supporting KMM, but now they are supporting. They are Kotlin first as well. So there are a lot of libraries now, and the folks are catching up. It's still not at a very good pace, and that's, I guess, understandable, because still folks don't use KMM a lot. but I would say yes, the adoption has increased a lot.
Got it. Yeah, I think one of the first libraries which I also saw was reactive, because
Okay.
I have
Yes.
been into like reactive programming, and like I was also observing like what is happening in Kotlin multi-platform world.
Yeah.
So reactive was one of the first libraries, I think.
I think reactive with a K, I guess.
Correct, correct.
It was,
And that was also not from a bigger organization. I think that
Yeah.
there was a developer, and yeah, we'll also be sharing all these links in our YouTube
Yeah.
description. But yeah, I think the adoption is getting increased by a lot, and
Yeah.
comparing to when you have used, I think now Firebase also has a Kotlin multi-platform.
I don't know. I don't think they have a native like a in-house support, but I think some open source solution you can find now.
Oh, okay, okay, correct,
Yeah,
correct,
yeah,
correct. So this structure we achieved, and we have also like discussed about the libraries.
Yeah.
Now, when your app is actually ready,
Yeah.
and it's ready for both iOS and Android,
Yeah.
how was the release pipeline and how was the distribution like it looked like? And I'm assuming uh, was that borrowed from something already present, because there would be some kind of scripts which are already there in place to ship your Android and iOS apps, like which is like portable to any kind of project.
Yeah.
So did you need to do any kind of changes, and what were the changes exactly, and what was your experience around it?
So Android had like support from day zero. Like I think at that time, so the challenge or the goal was that KMM was living in a separate repo. So the moment I ship a new tag to a KMM repo, it should trigger a build, which should generate two frameworks, one for dot framework for iOS and one dot AR file for Android, and that too with versioning as well. Right? So you have to make sure that the versioning is maintained the same tag that you are pushing for the KMM as well. Now I won't talk about the nuances of iOS because that will be too iOS specific talk, I guess. But I think like what you can rather do is that for CocoaPods that we use for iOS, it doesn't have a native support yet. Even now, I don't think you can just tell the URL of a Kotlin code base, right, to a CocoaPod. It needs to understand Swift, or it needs to understand Objective-C framework file. So at that point of time, there was zero CocoaPod support at all. So there was no scripting available, no CocoaPods available for me. But on Android side of things, I had Maven Publish with me. Maven Publish is a plugin that you can use as a Gradle plugin, a Gradle task, which publishes your locally generated AR file to a remote location, which could be Maven Central, which could be GitHub or whatever. Okay? And how do you make that AR file? So you have Gradle task for that. I don't remember the exact name, but I think if you call Gradle assemble, I think it will make you a debug and a release framework, I guess, for that, right? So once you make a framework which is locally available, then you can simply use a Maven publish plugin. It will ship your file to your remote location. But this support was not there for iOS.
So right now also it is not there, like CocoaPod.
Yeah.
So what
Yeah.
was the approach that you took to publish that dot framework file that you had for iOS?
So there are multiple approaches that you can do. One is more, let's say, community accepted solution, and one is more not opinionated, but it's a hack, but you can use, right? So the way CocoaPod works, I'll skim it very fast. So the way CocoaPod works is that you have two files, a pod file and a pod spec file. Pod file is what the consumer use, that is the who are the app makers. So in the app makers, they mention the name of the pod in their pod file. So for us, they will write the KMM library name, right? And then they have to, along with the name of the pod, if it's a private pod, they have to specify URL as well. This URL is not the location of the framework file. The URL in a pod file locates to a pod spec location. So pod spec is a file which the publisher of a library maintains, where it's like a config file which has the name of the library, the version of the library, the dependency attached to it. Is there a sub pod attached to it? what sort of framework you're looking at, all those things. So podspec is a config file, but for iOS. And you can specify like the local source file as well. So if I'm making an iOS project, I'll specify the local source location of the Swift files or Objective-C file. But in my case, I had to tell the podspec what's the location of the framework file, because that it also supports, right? So if you look at from the consumer point of view, consumer makes a pod file, they add your KMP project name, and then along with the KMP project name, they specify the KMP project URL as well. That's the URL has the location of a pod spec, and the pod spec knows how to get that framework file. So when you do a pod install, the pod spec gets the file for you, gives back to pod file, the pod file takes the framework file, gives back to iOS. So that's how this entire chain works. Now the pod spec gets a little tricky to use, because the pod spec location and the framework location matters. Right? Now pod spec and the framework needs to coexist together. You can't host a pod spec somewhere else and a pod file. You can't host a pod spec somewhere else and a framework somewhere else. They have to coexist together. So one approach is that when you do a pod install, we can attach pre-hooks and post-hooks, right? So when you do a pod install, one approach was that you manually download your framework file somewhere locally in a machine. So that's one scripting involved. So you can simple bash script that you can write, and that bash script downloads that project file or .framework file from the GitHub repo, which is you hosted somehow. We'll get back to how we are hosting a GitHub repo. So let's say you are able to host your framework file in a GitHub repo somewhere. So this script that you wrote will download that file from and will save it somewhere in the local folder. Now podspec will have the location of this local folder that you have, right? And then because the podspec needs to be the same machine that your framework is, so you can actually ship the podspec with the pod file as well. Traditionally, podspec needs to be with the publisher of the library. But in this approach, you can actually ship podspec with the consumer of the app. So I can locally refer my pod file, which locally refers to podspec, and podspec locally refers to the framework file. Because I wrote a download script which downloads the framework file from remote to a local machine.
Got it.
This is a very local approach that you can use, and not the most recommended way. It's a hack in a way, but you can use it, right? I had to dig deeper into CocoaPod to understand this is how we can use it as well. So it's an interesting way of using CocoaPods that you can use. So if you have podspec, pod file framework in one machine, you can simply use CocoaPods very easily. No hustle there.
Got it.
But in our use case, we went with the other approach where we made a fourth repository. So right now we have 3 repositories, one for iOS, one for Android, and one for KMM. So we wrote a fourth repository called KMM library or KMM SDK, which hosted the framework file in the podspec file, and also the Maven library that we published. Right. So this repo was holding all the artifacts, the Android artifacts, the iOS artifacts, and the iOS podspec file as well. Right. So this is the fourth repository. So now when you run a Gradle plugin from the publisher point of view, you are done with your Kotlin code. You're done with that. Now you can run 2 Gradle tasks. The one Gradle task will generate a .ar file for you, and you can use Maven publish to publish it to the CocoaPods to the GitHub repository, and then you can write a custom Gradle plugin which takes the artifacts of iOS, which Gradle provides by default. So Gradle allows you to generate artifacts separately for ARM and separately for Intel, but then you have to combine them together to a fat framework. Now we can use XC framework as well, and now CocoaPods have Gradle tasks attached to it, which can give you these out of the box now. So now adding things or using CocoaPods is a little bit easier now, but at that time there was no support at all. We had to manually tell Gradle that, hey, download the framework file for ARM, download the framework file for Intel architecture, and then use a custom Gradle plugin to combine them into a fat framework. Right? It doubles the binary size, but that's how you had to do it at that time.
Got it.
And then you ship this as a .framework file to a GitHub repository. So you can write a simple upload script now. So using bash, you can simply upload this framework file, which Gradle will produce it for you, and host it to a GitHub repository.
Got it.
So yes, it sounds a lot complicated. It sounds too many hoops and too many steps are there. But at that time, that's how things had to be done, because there was no other way around. But if you look at one by one, it's not a very big problem to solve. The way I solved the entire thing was that I broke this problem into small engineering problems, where the one problem was how to generate a local artifact first of all. Once I solved that, I moved on. Where can I host it? GitHub is the obvious choice because it's free and you can host it there, right? So I thought how to upload that file. So you have bash support for you, right? You can use any scripting language you want, and it'll take the artifact that's present locally, right, with you, and upload it to a GitHub. Once that was solved, then I moved to my next problem, that how does CocoaPod download this thing?
Got it.
Right? So CocoaPods, at that time I was trying out a different approach. So I wrote my own downloader as well. So I wrote a simple download script which downloads the CocoaPods, which downloads the .framework file from GitHub and saves it locally. And then the pod spec knows the location of this locally saved file, which the pod install can use it basically.
Got it.
Right? So that's how. So these small problems were solved, and ultimately I was able to like piece all this together and use it. But now the more modern approach is a little different than this. The modern approach now is that the fourth repository that you made, that can host two files, the framework file and the pod spec file, right? And now in my pod file, I can refer the remote location of this pod spec as well.
Oh,
right.
That was not there.
That was there as well at that time, but it was a little difficult to use with private repos, right?
Got it.
Because I don't remember if we had tokens at that time or not. Because at that time maybe we had to do something with .NET RC file as well. It's a way you provide credentials to a remote private repositories. You can still do it, but now with tokens things are a little easier now. That you can supply the tokens in GitHub secrets maybe, and then your CI/CD will pick the token from that, and also download the CocoaPods can also download the repository directly now. So now actually there is no scripting involved at all. I think all you have to do is you don't have to even upload your artifacts anymore. You can actually commit your repository, commit your .framework file as like a regular repo as well.
Got it.
So because that repo is dedicatedly for SDK purpose only, there is no code in that repo. If the purpose is only one, that is use it as an artifact repository.
It's kind of an SDK.
Yes. So I can, because that's the pattern that I saw other folks using it as well. If you look at any private company who have public facing SDK repos, they also do the same way.
Got it.
Because there are a lot of private companies, they can't expose their code base, but they somehow have to make it publicly available to everybody, like for us to use it as well. So that's how they use it as well. They host it in a repo, they host the pod spec, and they host the framework in that same repo as well. So that's a strategy. Now we are able to use it as well. That is in that separate repo. I can use it to host my pod spec and my framework file. And now my CocoaPods can simply fetch it for me as well. So now there is no upload script or download script. I can just commit my framework file to a new repo and also push a new tag as well. So that every pod spec, every framework also has a versioning support as well. And once I push that to a SDK repo, my pod file simply has this remote location of the pod spec file.
Got it.
So once I do a pod install over HTTP protocol, it can simply download the file for me and install it to the iOS. So now setup is a little more easier, I guess.
It sounds like that once you have R file and the .framework file, then you can just like get them to the private Android and iOS repos, and then like everything will be just use the script to build an APK, and then here to develop a IPA or a, iOS simulator app.
Correct. Because archival is still the same process.
Correct.
Because it doesn't matter to the archival process whether you're using KMM or not.
Correct.
Because for archival process, you archive your iOS code base or you archive your Android code base, and KMM is just like a third-party dependency, right? So there is no change in the archival process. That is how how do you export your APK or IPA. That remains same. That's again the beauty of this approach. But all you have to make sure is how do you attach that framework to your projects. That's where all the complications came, and we figured it out at the end.
Yeah, that is really interesting. I think release is only one thing which I found really like kind of complex.
Yeah.
But I think once you have that solved locally and remotely, I think it's doable. It's nothing different.
And now, and if you think that this is sounding very complicated and you don't want to spend too much time on this process and you want to focus on your app making, there are tools now that you can use. For example, TouchLab has this tool called KMMBridge, right? So we can say it's an out-of-the-box solution that you can use right now. That's the KMMBridge solves this exact same problem. How do you export iOS framework, right? So if you don't want to delve into all of this like complication of CocoaPods, iOS, SPM dependency, and all those things, you can directly use their plug-and-play library, I guess. So I've used it on an overview level, but I guess it works nicely. So you can use that. So as I mentioned, community is also adopting a lot of community is also solving these problems now, because over the period of these couple of years, people have shared the same problem again and again with everybody that KMM is good, but how do you generate artifacts? How do you release it to your iOS team? So these problems are solving now, like step by step.
Yeah, I hope this podcast will motivate other developers as well to kickstart and to persuade like their developers to do a POC on Kotlin Multiplatform, and maybe we are able to convert them to production users as well. So thank you, Ritesh, for your time, and
Thanks so much.
And we'll meet you in the next episode.
Sure. Yeah. Thanks for having me. Thank you so much, Amanjeet.